So get, post, put, delete, these are all the REST API verbs, you can say, that you can use in order to, or you can say methods or verbs basically that you can operate on the Elasticsearch. So basically is to delete all indices. I don't want this, so basically I will say delete, and now this is the way to, delete. You just name anything, let's say attraction, basically just see if it works. Played. Yeah, so Solar and Elasticsearch and MongoDB, that is a good question. So Elasticsearch and Solar, they both based on Lucene. So Lucene is basically one utility, or you can say basically it is a searching tool that is written in Java only. So internally, they all both Solar and Solar and Elasticsearch, they are running Lucene under the hood. Okay, and it is actually the kind of wrapper on the top of Lucene. So both Elasticsearch and Solar are mostly similar. Okay, Elasticsearch just gives the response only in JSON, while Solar will give you the facility of giving response back in either JSON or CSV, or you can say XML. Okay, so there are only those differences. Rest everything is similar. Okay, but I think any one of them is not free, or like Elasticsearch, it's a company, and Solar, I think it's open source. So let me just check. So we need to create this mapping. It is very important. I'll just save it somewhere. Twitter alias mappings. Because we are going to require this. So we are going to get now we just need to know how to search the things. Basically, where is my, here it is. What happened? So replication between nodes synchronized. Apache Solar versus Elasticsearch, the feature is Smackdown. but both are Lucene based tools. So Solr, Elasticsearch. See, Solr can give the response back into XML, CSV, JSON. Elasticsearch can give only into JSON. Both are HTTP REST-based API interfaces. Binary API Solr, that is okay. JMX support. States are exposed through REST API. So JMX and official client libraries Java, Java Groovy. Oh, sure, that is official client libraries .NET JavaScript. Community client libraries, third party output. So output is in JSON, XML, HTML via plugin. So this XML, HTML via plugin. So there is no native support for XML. So it gives the output only in JSON, and it gives output in this, XML, JSON, PHP, Python, Ruby, CSV, Velocity, XLT, native Java. Okay, why? I mean, what is the output? Because since JSON is a schema based, JavaScript object notation, so that can be easily changed, because even Python is having some data type, right? So the data type can be, even it can reply in Hive or Pig or whatever, right? So what we just need to do is we just need to send the record as a schema with the Python data or data types, or Ruby data type, or CSV, Velocity, whatever, right? Then on the infrastructure side, basically you will see this is Solr, this is Elasticsearch, indexing. There are multiple things, but what I was knowing is only this, right? Both are Lucene based. So these are some commands that you can run. So get search, if you do, there is no copy you can do. So it will search, I think, everything. So it is doing Twitter, attractions, and so it is actually showing everything that is stored in Elasticsearch. Full search example with aggregation, highlighting, and all. So basically, then you can pass query. Okay, so query would be match only with something like Smith. So this is actually the word that we are actually going to search into it. Okay, that you can do. Then common queries is multi-match query, fields, and types. Okay, so here you can see like that. Complex search, search all fields, all search in the default all field, basically. So these are actually REST based ways of searching. Create an index with settings and mappings. So if I do put, and the name is my index and setting is like that, and then you need to create mapping, type, and analyzer. So if I just give it like that, so this is, it will actually create. It will create first my index, and inside that index it is going to number of shards, let's say only, let it be like that. So mapping name would be my type name. Okay, so this is the index that is going to be created, this is the table that is going to be created, and these are the actual fields inside it, type and analyzer, which we can then put some values to it. So let me put it. So So if it is all okay, it will give me that. And on the Elasticsearch side, basically you should be getting there is some error, right? Plugin status change from yellow to red, request timeout. Status change from uninitialized to red. Elasticsearch plugin is red. Because the problem is when we are actually creating anything, it should give us some response back on the Elasticsearch, and that's why actually it's not happening. We can also do through this with the browser, I think. But they say Kibana should work, right? It was working, what happened? So we are running 5.2, there is no version problem. Here everything is info, so Elasticsearch is proper, but in here plugin status change from initial to green ready, then request timeout 3000 milliseconds, maybe need to restart it again. Failed to process cluster event, delete index or directions or on a cluster. So this is what actually we were trying to do, and now it is actually bombarded with this my index, right, we are actually trying to create and it is failed to process. Deleting index also, let me just stop it as well. I think there is a problem. Let me just stop this VM. Actually, it could be. So let me off this VM and then we will try it. Maybe I'm not sure. Yes. Oh, now it is okay. So I think due to that VM, and I think it was actually stucking in. So now it is okay. If I go to Kibana and put my index, so it says acknowledge true, shards knowledge. So basically we have created one this is this is database, and this is actually a table. Okay, now this is how you need to interact. Now this is some weird way. I mean, this is not like create table, create database kind of thing. It's completely in JSON format. Now how to put okay, so whatever is inside this, right? Basically, you just need to go through. I mean, how, because this is all like you need to understand how to put the data, how to search the data, how to update index setting dynamically, update an index by adding a field to update, get the mapping, create document, just like title. Elastic is funny. So post. So basically, if you see, these are the field type and analyzer. So sorry, title is only the field, sorry, and its type is text and its analyzer is English, or maybe something like so. It's only title. And what about tag? So tag is something that we are actually giving. So if I say post, okay, so it is going to feed one record called elastic is funny. Okay, so I will copy this and do this. So index type ID, this is ID of the document. It means document means what? That is basically the record that is getting added. Okay, so it's that ID. So every record is actually identified by its ID. Okay, and total 2, successful 1, failed. So created true. So basically we have created one record within that. So this is database, you can say index, and this is mapping, that is what is called table. And within that table we have created one record with the field name is this and its value is this. Okay, now create or update a document, delete a document, remove, and how to search list, aliases, simple, reindex, post, debug. So get a detailed view of what a query do. If I do this, so 404 mean bad, it did not find. Okay, so if I say match title with this bit, but what title did we put is funny, right? So if I say something elastic, funny, I think this is what that. So it is bad. So you just need to understand all this thing basically, and try to do some get post out of it. Okay, what we are going to do is basically if you try to let me just delete this. Basically you just need to say get underscore cat. It will give you all the indices and my index name, right? So this is the index that is actually we have created. So if you just want to delete it, just do delete and index name. So that whole database got deleted. Okay, so this is actually what I know. These are very simple things that we can do. Basically you can get, post, delete, whatever about it. So we have our Twitter things available on my, so that is the mapping actually we need to create for Twitter. Let me tell you what actually it is that so the name of the table is going to be tweet. Okay, and Twitter is the index in which the tweet is the table, and in that table basically we are having these are the fields: properties, hashtags, okay, then language, location. These are all the points that we are going to collect from the Twitter feed. Then what place, whether retweet, text, and user. Okay, so these are some few fields that we are going to collect from our Twitter feed. Okay, so let that mapping be there. Now if you want to visualize the things, come here and go to first management. There is something called index pattern. So you need to search that. You need to select that index pattern, and basically currently Twitter is our currently we have selected Twitter as our source for index. Now basically what you can do is I can delete this attraction. Okay, so there is nothing. Okay, so basically when you go to index, when you go to management, so you just need to provide Kibana the basically the information that which particular index it needs to search, okay, in order to make the visualization and all. So you need to go to management console and here come to index pattern. So currently it says that there might be something called log stash index available in your Elasticsearch, but currently we do not have any, right? So what indexes we do have? Only either attraction or what was this? Basically go here and just do get underscore get all indices. So only two indexes are available, Kibana and Twitter. Okay, so we will search something with Twitter. So basically if you go here, go to management console and go to index pattern, and we need to define index for this. So basically index come here and do Twitter, and anything that is actually having Twitter in it basically will be selected. So it actually found it that there is some Twitter indices available in our Elasticsearch, and it tells that time field name. So there is one time field name called created at. So if you see here, created it. So this created it is basically the field whose type is date. So it actually automatically found, it automatically detect that there is a timestamp or date timestamp kind of field is there already. So I'm going to create a new searching pattern or index pattern basically. And now if you do create, basically it will actually create it. So this is Twitter. Now we already have defined the mapping in terms of that. So created it is a date type, then language is string, source, location is geo, place, text, user. So these are all, this particular is the fields from that Twitter table, Twitter index, tweet table, and this is actually the information from that. So it automatically tells you that what is the type of thing, because it is already JSON, so it is already structured things. So this geo point is very important in order to, whenever you tweet from somewhere basically, and if it is having your longitude and latitude, basically it is going to map it on. So we have defined this mapping. Now go to visualize. Basically if you do okay, now if you go to visualize, basically there are multiple things. Either you can create a line chart or data table or area chart, or these are also, you just need to try them one by one basically. Okay, so currently I say discover, now we do not have any things to search basically. Things come out. If you select pie chart, select this index called Twitter, index pattern, then you can do split slice based on so currently we do not have any data to in that particular. So what I will do is basically I have created this overall Twitter feed that is going to feed our tweets. Okay, so this is a user created location, text, hashtag, tweet, retweet, language, and place. So we need to understand what it is basically, and then we will run it, and let's say if we will get some data over there. Okay, so at least our Kibana and Elasticsearch, they are actually interacting and give us some results back. Okay, we will do further on it. So it is 9:20, so we will take a break, and then after break we will understand this thing and we will try to run it. Okay, so this is completely Scala code. Okay, not big, not more than some few hundred, 80 lines around it. Okay, so I will stop the recording here and let's take a break. We'll meet at 9:50.